RMS value of AC. The root, mean, square RMS value of the current is the steady current which in the same time would cause the same amount of energy to be dissipated in a resistance Joule seating as does the alternating current. It is also defined as the square root of the average of the square root of the instantaneous value of the currents over a complete cycle. It is also known as effective value of current or virtual value of current. IRMS equals to square root of average I square, but I equals to I naught sine omega t. Average I square equals to integration from 0 to t of I square dt by integration from 0 to t of dt, but cos 2 theta equals to 1 minus 2 sine square theta gives 2 sine square theta equals to 1 minus cos 2 theta gives sine square theta equals to 1 by 2 into 1 minus cos 2 theta. Average I square equals to I naught square by t integration from 0 to t of sine square omega t dt equals to I naught square by 2t integration from 0 to t of 1 minus cos 2 omega t of dt equals to I naught square by t into t minus sine 2 omega t by 2 omega from 0 to t. Average I square equals to I naught square by t into t minus sine 2 dot 2 pi by t into t by 2w equals to I naught square by 2t into t. Average I square equals to I naught square by 2. IRMS equals to square root of average I square equals to square root of I naught square by 2. IRMS equals to I naught by root 2. IRMS equals to 0.707 I naught. IRMS equals to 70.7% I naught. Similarly, consider the equation E equals to E naught sine omega t. ERMS equals to E naught by root 2. ERMS equals to 0.707 E naught. ERMS equals to 70.7% E naught. Relation between average value and RMS value. Average I equals to I average equals to 2 I naught by pi. Therefore, I naught equals to pi by 2 I average, equation 1, and I RMS equals to I naught by root 2. Therefore, I naught equals to root 2 I RMS, equation 2. From equation 1 and 2, we get pi by 2 I average equals to root 2 I RMS. I RMS equals to pi by 2 root 2 I average. AC instruments measure the root mean square value. Therefore, when we say that the supply voltage in our homes is 230 volts, we are talking about RMS value. Form factor. It is defined as the ratio of RMS value to the average value. That is, form factor equals to I RMS by I average equals to E RMS by E average. Now we know that I RMS equals to I naught by root 2 and I average equals to 2 I naught by pi. Therefore, form factor equals to I RMS by I average gives rise to I naught by root 2 by 2 I naught by pi gives pi by 2 of root 2. Form factor equals to 1.11. The physical significance of form factor is that it gives us identification about the wave shape of alternating current or voltage. Thus, for a sinusoidal wave, the form factor is 1.11. For non-sinusoidal waves, the form factor can be more or less than 1.11. For example, for rectangular wave, that is, steady DC currents, the form factor is 1. And for a triangular waveform, it is 1.15.